This question is about the de Broglie wavelength and comparing the de Broglie wavelength of a beam of electrons with a beam of protons. So we're told that the two de Broglie wavelengths are the same. So the de Broglie wavelength is h over the momentum, so h over p. So that is h over the mass of the electron, velocity of the electron, and that's equal to the de Broglie wavelength of the proton beam, which is given as that. So I can take this second part, if you like, and we end up with the h's cancel, so you end up with 1 over MEVE equals 1 over MPVP, which basically must mean that the two momentums are the same. So we end up with this. Now I'm asked for the speed of the electrons, so I'm asked for this one. I know the mass of an electron, I know the mass of a proton, I know the velocity of the protons because I'm given it in the question. So I can rearrange for this value, so I get VE is the mass of the proton over the velocity of the proton over the mass of the electron. So mass of the proton 1.66 times 10 to the negative 27. Velocity of the proton beam is 2.8 times 10 to the 4. And then the mass of the electrons is 9.11 times 10 to the negative 31. So those of you who are sort of a bit sharper might spot that this is going to be that sort of nearly 2,000 value, so it's going to be about 2,000 times more. So I can look already, because the ratio of the mass of a proton to the mass of an electron is about a ratio of 2,000, I can look at this already and see what value is going to be about 2,000 times more than this. And there's only one value that's 2,000 times more than it, and that's already, I can clearly identify in the question, but I will check that what I'm doing is correct. So 1.66 times 10 to the negative 27 times 2.8 times 10 to the 4 divided by 9.11 times 10 to the negative 31. And I get 5, lots of numbers. I can use the E and G button again to help me. So I get 51 times 10 to the 6, which is 5.1 times 10 to the 7 meters per second.